These are the notes that are going along with 3.2, Identifying Forces and Free Body Diagrams on page 5. Instead of loading this Moodle lesson, you're watching this video. Write your answers from the lesson in this packet. Again, this is page 5 of the packet. Sir Isaac Newton developed 3 famous laws of motion. This activity will explore Newton's first law of motion, or the law of inertia. This law will include the discussion of forces. So on this page, we're going to talk about a bunch of different forces. A force, which we can write with capital F, is any push or pull. A frictional force is a force that acts between materials that touch as they move past each other. We'll talk about that later on the page. The SI unit, the standard unit for force, is the Newton, abbreviated with a capital N. Notice the word Newton has a lowercase n. It's named after this guy, Sir Isaac Newton. When we name units after people, we write the unit with a lowercase n. To get an understanding of what a Newton is, 1 kilogram weighs about 10 newtons. Alright, so that's about 2 pounds. About 2.2 pounds is about 10 newtons. Alright, types of forces, fill in the blanks using the information from this video. The force caused by gravity, we call that weight. So weight and mass are going to be different because weight is a force caused by gravity. It's always directed toward the center of the earth or whatever is causing the gravity. The variable for the force of gravity or weight is F sub g. F sub g. Sub means small, so we got the big F for force and the small g for gravity. A force that resists the motion of 2 objects in direct contact is called friction. The variable for friction is F, capital F for force, and then lowercase f for friction. That's F and a lowercase f. Force of friction, force of friction. Okay, so friction, by the way, is like when we've got a box. When you slide it on ice, it slides really quickly. Woo! But if you were to slide it on wood, if you try to push it on wood, it doesn't move as quickly because there's that force of friction. There's also friction even when things aren't moving, but we'll talk about that in class. Okay. A force exerted by means of connection with a rope is called the tension force. And the tension force always pulls on the bodies to which the rope is attached. So anytime you see ropes or wires or cables, strings, we're always talking about there's always a tension force. The variable for the tension force is, you might have guessed, capital F and a small t, force due to tension. Here's an example of the tension force. We've got a person holding a box. There's the force of tension, the tension force in this rope here. This is a rope. It's tight because of the tension force. Air resistance, or drag, is a force that opposes motion through a fluid such as air. Air resistance. Or drag. Drag is kind of the more general term for it. Drag increases as speed increases. So the faster you go, the more resistance you get from drag. And we have something called terminal velocity. That's what happens when the drag force for something falling equals its weight, so that it doesn't accelerate anymore. It just keeps going the same speed once it reaches terminal velocity. The variable for the drag force is F sub d, force due to drag. So that's like when you're trying to move a heavy box by pulling it, and you're trying to pull it along, but it's dragging backwards, right? It's got a force of drag and it's pulling backwards while you're trying to go to the right. After that, we have the force when one object acts on another. This could be a push or pull. That would be the applied force. The variable for an applied force is, you may have guessed, capital F and then a small capital A. Or you can label each force F1, F2, etc. To give you an idea what I mean, here's a picture. We've got two people pushing on this box. This guy's got an applied force pushing that way. But if we wanted to, since there are two guys here, we could say instead of FA, we could say that's F1, and then F2 is coming from this red guy pushing that way. So if there's more than one applied force, you can label them F1, F2, F3, F4, etc. Okay, the normal force is a force that occurs when two objects are in direct contact. It's always directed perpendicular to the surface of contact. Perpendicular means at a right angle. So if I've got a table here and some box on it, the table is pushing up on the box with the normal force. And like we said, it's always perpendicular to the surface. So here's the surface. It makes a right angle right there, 90 degrees. That's the normal force. And the variable for the normal force is F sub n, the force due to the normal. In math, normal means perpendicular. So it's not normal in the sense of the usual force. It's actually a very specific word that's mathematical origin. Alright, now you should be able to finish your homework.